Hi everyone, I'm going to do a demonstration of a type of reaction that you learn about in chemistry. It is based on a reactant, a single reactant. We are going to use this reactant, hydrogen peroxide. The formula for hydrogen peroxide is H2O2. And we are going to end up forming two products. We're going to see the evidence of these products. Let me see if I can see that. That's right in the glare. We're going to see the evidence of these products when I demonstrate the reaction for you. I do want to note that you may have seen this reaction in videos, or you may have even done it. This is also known as elephant's toothpaste, but this demonstration I'm doing for you is not using 3% peroxide that you would buy at a store. This is using 30% peroxide, which is like what you would buy to clean a pool. This is very strong, so I'm wearing gloves and things, and you should not do this at home with 30% peroxide. You may do an experiment that's elephant toothpaste using 3% peroxide and a common household substance. So I have peroxide measured. I actually have 20.1 milliliters measured. That may be a question that you have to answer. I have 20.1 milliliters of 30% mass by volume peroxide solution. That may or may not be something you need to answer a question about. And it is indeed a solution in water, so it's aqueous. Something that we have to add to our peroxide to make this reaction happen in a fast way is what is known as a catalyst. And for this reaction, one type of catalyst you can use is a compound called potassium iodide, Ki, potassium iodide. It is also going to be in solution form. This compound is mixed with water. Catalysts are often written above the arrow because they are not a reactant and they are not a product. They are its own class of substance, a catalyst. So here's our catalyst, a solution of potassium iodide. And for it to be elephant toothpaste, we got to have a little bit of soap. The soap is not actually part of the reaction either. The soap is just there to create bubbles that will trap one of our products. Sometimes when we make elephant's toothpaste, we also add a little bit of food coloring to make it, look more like a toothpaste, a colored toothpaste. So I just add a little bit. You do not have to do that part in a reaction. And once you're ready, you just pour your catalyst into your peroxide, and this reaction will happen. Ooh, okay. Now, maybe you can see in the video, I don't know, there is steam coming off of this reaction. There is steam. You probably can't see it. And there is heat coming off of this reaction. The steam is visible evidence that one of our products is indeed H2O. So this is H2O in the gas phase coming off of it. And the other product that I'm telling you made is O2, which is a gas, but we should be able to test for that by doing a splint test. So I'm going to light a wooden stick, or you could light a match, okay? And then I'm going to just gently blow it out. And when I stick the splint into the foam, that foam has trapped oxygen gas. And we know that oxygen gas is what supports flame. It supports fire. So there's two visible evidences, the steam and the reignition of a splint, that prove the two products that you make in this reaction. And so probably the last thing you will be asked to do for this reaction, other than writing observations, perhaps a kind of calculation, it just depends, maybe just recording the amount you used. The last thing you would have to do would be, of course, to balance the reaction and identify perhaps what type of reaction this is. You learn about reaction patterns that follow if you only have one reactant, what kind of reaction is